Hi, I'm Yohannes, a fourth-year medical student at Penn.
And I'm Drew, an instructor in neurosurgery at Penn. In BCI applications, scalability is an obstacle when trying to encode detailed tactile and proprioceptive information using brain stimulation. Thus, we designed a novel paradigm, testing rodents' ability to learn higher-level sensory feedback concerning the goals of actions.
Simulating electrodes were implanted into S1 and connected to a waterproof wireless neural stimulator. We challenged rats on a Morse water maze variant where the submerged platform moves after every trial, dissociating visual cues from platform location. Rats received goal direction information through microstimulation. Rats learned to use the artificial sensory cues to direct their swim toward the shifting, hidden goal. The rats swam aimlessly on catch trials where no stimulation was provided. Rat cyborgs in prior work learned only simple turning responses to cortical microstimulation. Our rats efficiently incorporated the encoded feedback into more flexible behavioral strategies to achieve the goal.
Our results suggest it's possible to encode non-native, higher-level sensory feedback with implications for both cognitive and sensory motor BCIs.